In 2.4, we'll be looking at using determinants to find inverses. And we can still find inverses in the way we previously have, but this is just an application of using determinants. So in order to do this, first of all, we need to remember that if we have a matrix A, if the determinant of A equals 0, then A doesn't have an inverse. So A only has an inverse when the determinant of A is not 0. So before we go straight to the inverse, we need to define a term. And this book calls it an adjoint. Some books call it an adjunct, or adjunct, actually. Adjunct. And first of all, to do that, well, I guess I'll go ahead and give you the definition. The adjoint of A is the transpose of a matrix B, where B is the matrix that's formed by getting the cofactors, the A11 cofactor, the A12 cofactor, A13 cofactor, every single cofactor of that matrix. And so forth. So the adjoint, once we get that, then we transpose it. So let's look at an example. We want to find an adjoint. Find one to do. Let's suppose we have 1, 1, 1, 0, 2, 3, 5, 5, 1. Let's suppose that's A. So for B, we want to sorry, somebody just went flying down the hall. Didn't know what was going on. We cross out row and column. We have 2 minus 15. So negative 13. Then if we go cross out row and column, we have 0 minus 15. But we do the opposite of that sign because row 1, column 2, that's 1 plus 2 is odd. So the opposite of that is positive 15. Row 1, column 3, we have 0 minus 10. Remember, positive, negative, positive. So then we go down to the next one. Cross out row and column. We have 1 minus 5. 1 minus 5, that's negative 4. Keep in mind this is row 2, column 1. 2 plus 1 is odd. A negative 1 to an odd is negative. So it's the opposite of this. So the opposite of negative is positive 4. As we work our way across, cross out row and column, we have 1 minus 5. If that was negative, then this is positive. So we use that sign. Then row, column, 5 minus 5 is 0. And now that I look back, let's see, row 2, column 1, 1 minus 5, negative 4. Okay, we do the opposite. Row 2. Sometimes when I go back and look, if I don't make my marks, then I lose where I am. Okay, so those look good. So then we go to the last row. Mark out row and column. We have 3 minus 2, which is 1. That's the third row, first column. So that's even. So we use the sign. Mark out row and column. We have 3 minus 0, so 3. But we do the opposite of the sign. Mark out row and column. 2 minus 0. Row 3, column 3, that's even. So we use the sign. So that's B. So the adjoint of A is the transpose of that. So if we transpose that, we have 13, 4, 1. The first column becomes the first row. The second column becomes the second row. The third column becomes the third row. So that should be our adjoint of A. Now that we've found the adjoint of A, let's see how we're going to use that to calculate our inverse. So the inverse of a matrix is 1 over the determinant of that matrix times its adjoint. Now keep in mind, this is just a number, 1 over some number. This, the adjoint of A, is a matrix. So basically we're going to multiply a matrix by a scalar to get our inverse. So we have our adjoint, we need our determinant. So A was this. So let's bring A over. So if we want the determinant of A, several ways we can do that. The first way that jumps out at me is if we put this in upper triangular, then we can multiply down the diagonal, and we can get this in upper triangular quickly by doing negative 5 times row 1 plus row 3. So our first row is the same, our second row is the same. Negative 5 times the first row is negative 5 plus 5 is 0. Negative 5 plus 5 is 0. Negative 5 plus 1 is negative 4. Remember, if we get a row by doing a sum of a scalar times a row, then that doesn't change our determinant. So this determinant is 1 times 2 times negative 4, which is also the value of the determinant of A. So the determinant of A is negative 8. So if we take that determinant and our adjoint, we can get our inverse. So let's get our adjoint. So if we bring our adjoint over, let's paste that down here. So we're going to take that adjoint and multiply it times 1 over our determinant. So this is going to get multiplied times each element. And this is going to be the inverse of A. So if we multiply this out, we do it times the first element. 2 negatives make a positive. 13 over 8. 4 over negative 8, that's negative 1/2. Negative 1/8. Negative 15 over 8. Negative 4 over negative 8. Negative 3 over negative 8 is positive 3/8. Negative over negative is positive. That times 0 is 0. That times 2, 2 over negative 8, so negative 1/4. So that should be our inverse of A. Okay, well let's use MathCAD to check to see if that really is the inverse. So I've taken MathCAD, I've defined our matrix A, I've defined AI as the inverse of that. So let's do that product. Let's do A times A inverse. Let's see what that gives us. Notice that gives us the identity matrix is 3 by 3. So yes, that is the inverse. By definition, when we multiply a matrix by its inverse, we get the identity. So that is the correct inverse. So let's do another one of those for practice. I'll do another 3 by 3. You can do a 4 by 4 for practice if you like. Let's look at number 8. Number 8, we have 3, 1, 0, 1, negative 1, 2, 1, 1, 1. So we need to get the adjoint. So let's get B first, which comes from finding all of our cofactors. Remember, our signs will be positive, negative, positive. Row 2, column 1, so negative, positive, negative. Row 3, column 1, so positive, negative, positive. So we're going to do this, whatever we get, the opposite of it, whatever we get, the opposite, get, opposite, and so forth. So I'll just leave those there as we go. So for our first one, if we cross out row and column, we have negative 1, minus 2. So minus 3, and we use that sign. Then if we cross out row and column, we have 1, minus 2, so negative 1, but we want the opposite, so 1. Row 1, column 3, you have 1 minus a negative 1, so 1 plus 1, that's 2, and we use that sign. Next row, cross out that row and that column, so 1 minus 0 is 1. We use the opposite, so minus 1. Row and column, so 3 minus 0 is 3. We use that sign. Row and column, you get 3 minus 1 is 2. Do the opposite, so negative 2. So then third row, so cross out third row. First column, so 2 minus 0, so that's 2. We use the sign. Row and column, so 6 minus 0, do the opposite. So the opposite of 6 is negative 6. Row and column, negative 3 minus 1, so negative 4. Use that sign. Negative 4. Just glance back. Okay, those look good. So that's B. So the adjoint of A is the transpose of that. So if we take that and transpose it, our first row becomes our first column. Our second row becomes our second column. Our third row becomes our third column. Or you could say first column becomes first row, second column, third column. So that's the adjoint. Now we simply need the determinant of A. So if we take A, we can either expand or we can do some row operations. So I'm going to do row operations. to simplify this down to get, this will let me move this, to get the determinant of A. So let's change this to a determinant. So if we want a 0 here and a 0 here, the second row we're going to do minus 1/3 row 1 plus row 2. And I'll tell you what, instead of that, let's do this. Let's multiply the first row by 1/3. So if we multiply the first row by 1/3, we get a 1, a 1/3, and a 0. And the other ones are the same. So we need to think about this for a second. So this is 1/3 of that. This determinant is a third of that one. So if we want this determinant to be equal to that one, then we need to take 3 times that amount. If you think about 3 times that first row, that'll give you that one. All right, so now with a 1 in that pivot, let's get rid of these. So row 2, let's do the opposite of row 1 plus row 2. For row 3, do the opposite of row 1 plus row 3. So the first row stays the same. We're doing minus this plus that, so 0. Negative 1/3 minus 1, that's minus 4/3. Negative 0 plus 2 is 2. Negative 1 plus 1 is 0. Negative 1/3 plus 1 is 2/3. 0 plus 1 is 1. So now we need a 0 here. So we need this to be a 2/3. So if we've got 4/3 and we need it to become a 2/3, then we need, what, half of that? Half of that would give us negative 2/3. So our new third row, we're going to do half of the second row plus the third row. And remember, for all 3 of those, since we're adding a scalar of one row to another, that doesn't change the value of our determinant. So if we do 1, 1/3, 0, 0, negative 4/3, 2. Now for the bottom row, we're going to do half of this row plus that one, so 0 plus 0. Half of that is negative 2/3 plus 2/3 is 0. Half of that is 1 plus 1, so 2. So this determinant is 3 times, multiply that down the diagonal, so 1 times negative 4/3 times 2. Notice the 3's cancel, so 1 times negative 4 times 2, so negative 8. So that's the determinant of A. Now that we have our adjoint and we have our determinant, now we're prepared to get the inverse of A. So let's get our adjoint. Don't want to rotate it. Let's get that. So that's our adjoint. Our determinant was negative 8, so we're going to multiply by 1 over that. And that'll give us our inverse. So our inverse, each element times negative 1/8. So negative times negative, that's positive 3/8. positive 1/8, negative 2/8, so negative 1/4, negative 1/8, 3 times that, so negative 3/8, negative 6 over negative 8, so positive 3/4, 2 times negative 1/8, so negative 2/8, or negative 1/4. That's just the opposite, so positive 1/4. Negative 4 over negative 8, that's positive 1/2. So if we did everything correctly, that should be our inverse of A. So I guess we can check that by putting that in the MathCAD. So our A, let's clear this out. Insert a new matrix. A was 3, 1, 0, 1, negative 1, 2, 1, 1, 1. And then let's clear that out. So we calculated our inverse to be 3/8, 1/8, negative 1/4. 3/8, oh, didn't take it. 3/8, 1/8, negative 1/4. And I'll pause this while I type the rest of them in. No need for you to have to sit around and wait for this. So I finally got all those typed in. So this was our A. This is what we calculated our inverse to be. So when we do that product, yes, that gives us the identity matrix. So apparently we did calculate the correct inverse. So that's on using determinants to get the inverse. We can get the determinant of a matrix. We do 1 over that times the adjoint of that matrix. So again, if the determinant is 0, that's undefined, i.e. there's no inverse.